As we start to get into more and more trigonometry, we're going to find out that the pretty numbers don't always show up. In fact, in trigonometry, many of the values are approximate, so our answers are usually rounded to 4 decimal places. It's best to wait until the end of the problem before rounding it, though. If I keep rounding off parts of my problem, then it's going to create an answer that ends up pretty far away from what my original answer would be if I didn't round it. Okay, so last time we saw this triangle, we found the sine of theta and our 6 trig functions that dealt with theta. Today we're going to switch it up and we are going to try to find those 6 trig functions, but not of theta, of 62. It's not going to give me enough room. Okay, so whenever we are doing the sine of 62, the first thing we need to identify is what's our opposite, adjacent, and hypotenuse. So the opposite is the one that's across, so that's our opposite. Our adjacent is the one that is not the hypotenuse and is next to it. So that's the adjacent here. The hypotenuse is always going to be your longest side. If we remember sine is opposite over hypotenuse, which then means that we do the opposite of 62 over the hypotenuse. So that's 3 over 3.4. If I'm looking at the cosecant, remember it's just the flip of it. So that would be 3.4 over 3. Looking at cosine, almost said cosecant. Cosine is the adjacent over the hypotenuse. So that's 1.6 over 3.4. Secant is the flip, or the reciprocal of that. 3.4 over 1.6. The tangent is opposite over adjacent. So since tangent is opposite over adjacent, that would be 3 over 1.6. Over 1.6. And my cotangent would be the flip, 1.6 over 3. Now I can pull up my calculator here. Click on, and I can start calculating these values. It would help if I didn't have the marker pressed. 3 divided by 3.4. Let's try that again. 3 divided by 3.4. That's better. And you'll see here that this is a decimal that runs on. So let's go ahead and round it off to the 4 places because I don't have any more calculations left to go. 0.8824. And if I want to actually be technical here, these equal signs, I can make the squiggly equals, which means approximately. So that tells everybody that I rounded it off. Okay, now we can do 3.4 over 3. That gives you 1.13 repeating. Cosine of 62 is 1.6 over 3.4. Which is approximately 0.4706. .4 over 1.6. 2.125. And then tangent is 3 over 1.6. So that's approximately 1.875. That one's actually not approximate, that's exact. But then last one is 1.6 over 3. And that gives me approximately 0.5333. Okay, so those are my actual values of my 6 trig functions once I calculate them out. So we're going to have situations now as we move through trigonometry where we don't want to relate it back to this right triangle. I mean, it relates back to it, but do we want to draw the triangle out every time, draw a 62-degree angle, start labeling some sides and putting them in together? That's going to be more difficult for each time that we do it. But basically, all trigonometry is based off of this right triangle, these right triangle values that are given to us. And we'll see that whenever we use the calculators to evaluate the trig ratios. So I have my triangle, but I don't need it this time because I'm going to use my calculator to find these values. So if I bring up my graphing calculator here and I type in sine 62. Now, before I do that, I should go in and check my mode. Make sure that I am in degree mode because that's 62 degrees. So you push mode, come down to where it says radian and degree, go over to degree, push enter, second, and quit. And now we're back to our main screen. If I push enter now, I'm going to get approximately 0.8829. If I look back at my last slide, I had 0.8824. So it's close, but not exact. But you're going to find that this is actually the more exact of the two. I also may have written that down wrong. Let's try it. Do 3 divided by 3.4. No. So anyways, you see that it's not exact, but remember that this was an approximation. So I get 0.8829. If I do the cosine of that value, I get 0.4695. Let's compare that to our last cosine. 0.4706. The question is, how far off is that? Not very far off. It's pretty close. If I do tangent of 62, I get 1.8807. And if I look back, 1.875. So do we know what's accounting for these differences? One thing that could be accounting for it is that our original decimals would have been rounded off, like the 3.4 and the 1.6. Let's try cosecant of 62. Where's my button on the calculator for that? Yeah, you're going to find there is no button for cosecant. However, remember it's the reciprocal. Sine is opposite over hypotenuse. Cosecant is hypotenuse over opposite. So one way that we can do this is we can do 1 over the sine of 62. By doing it this way, it gives us the reciprocal. So that's 1.1326. Same thing for the secant. 1 over the cosine of 62 will give us that value. So I get 2.13. And then 1 over the tangent will give us our final value here. .5317. If we look back and forth between our numbers, we're going to find that they're all relatively close. 0.533 on the bottom, 0.5317. That's 2/1000ths of a place off. Look at the secant, 2.125, and this one is 2.13. That's 5/1000ths off. So it's not all that big of a difference when we look at it. It can mostly be attributed to probably rounding off within our actual triangle in the beginning. That takes us to special angles. Oh, they're so special. You're going to see a lot of triangles that end up being 30, 60, 90 or 45, 45, 90. What you'll find is that we end up with a short side in a 30, 60, 90 triangle. So this is our short side. Square root of 3 is a little longer than 1. And so whenever we end up with this short side in a 30, 60, 90, this one is going to be x. This next side, that's not the hypotenuse, will be the square root of 3 times x. And this side will be 2x. So if I work my way around the triangle doing that, that's going to tell me how each side falls. We did this in geometry. So each side, if this one is 1, this one is 2, this one's square root of 3. If this side was 2, then this would be 2 square roots of 3, and this would be 2 times 2, which is 4. If we go through our mixes of these, where we go through our 6 trig functions, I can do sine of 60, cosine 60, tangent 60, then cosecant 60, secant 60, and cotan 60. Instead of actually using the triangle now, I'm going to punch these values in. Sine of 60 gives me 0.866024. If we look at the triangle perspective, the sine of 60, opposite over hypotenuse. So that would give me root 3 over 2. If I punch that into the calculator, square root of 3, close my parentheses, over 2, it gives me the exact same quantity. Because this is a more exact answer, this is going to be the one that I want. I want root 3 over 2 whenever we see sine of 60. Cosine of 60, is going to be, we have the 60 here, opposite over, or I'm sorry, adjacent over hypotenuse. So 1 over 2. And then tangent is opposite over adjacent. So that's square root of 3 over 1, which is just square root of 3. If you don't believe me, you can check all of these in your calculators. Cosecant of 60 means that I flip this. So it's 2 over the square root of 3. The only problem with that is we're not allowed to have a square root in the denominator. So that becomes, we multiply top and bottom by root 3. So that becomes 2 root 3 over 3. Secant of 60 just becomes 2. And cotangent becomes 1 over root 3. Again, we can't have a root 3 in the denominator, so I have to multiply by the square root of 3 in top and bottom. That gives me root 3 over 3. So we finished with root 3 over 3 here. Sorry about the interruption. I'm like the most popular dude in school nowadays, now that everyone's not here. All kids are gone. Just Russell over here popular. Okay, now let's move on to the 45, 45, 90. So from geometry, if this is x, and then this has to be x, those are going to be congruent. And then this would be x times the square root of 2. In this case, we already have that this is a 1, so we can just move right into it. Sine of 45. Well, which 45 do I pick? Doesn't really matter, the exact same things. So opposite over hypotenuse is going to give me 1 over square root of 2. That's right, you can't have a square root of 2 on the bottom, so we have to multiply by square root of 2 on top and bottom. Square root of 2 comes up on top, times 1 is square root of 2. Square root of 2 times square root of 2 on the bottom makes this just 2. Cosine of 45. Now it's important to do that step, and I'll show you why. If we do the cosecant here, before jumping to the cosine, now it's just the flip of this, right? So that's just going to give me root 2 over 1, which is just root 2. If I didn't do that step, then and I was looking at my cosecant, it would be 2 over root 2. I would have to multiply by root 2 on the top and bottom again. I'd end up back at root 2. You still get there. There's just more steps. Cosine of 45. Let's see, that's going to be opposite or adjacent, which is still going to be 1 over the hypotenuse, which is the square root of 2. Multiply the top and bottom by the square root of 2. 1 times the square root of 2 is square root of 2. Bottom, square root of 2 times the square root of 2 is just 2. So I end up with the same thing. Now if I'm looking at the secant of 45, that's going to give me root 2. Moving on to tangent. Tangent of 45 is the opposite over adjacent. So it's going to be 1 over 1, which is 1. That makes the cotangent also 1. These are special angles because this is what a lot of our trig is going to be built off of. The 45, 45, 90 and the 30, 60, 90 angles. As a matter of fact, we have a beautiful little table here. This sums up everything we just learned on 30, 60, 90 and on the 45s. So make sure you copy this table down, and we'll pick up from there tomorrow.